It's my pleasure and honor to introduce our next speaker. Our next speaker is Arvind Krishna. Arvind is Senior Vice President and Director at IBM Research. IBM was present at the beginning of computation and analytics and data, and it's continued to lead and drive the development of that industry and those technologies we're talking about tonight. And in his role, Arvind has the, I'm sure, both fun and frightening task of steering that beast that is both ocean freighter and sports car. The work includes cognitive computing, quantum computing, cloud platform services, data-driven solutions, blockchain, and a whole lot more. Please join me in welcoming Arvind Krishna.
So it's always intimidating to try and follow the smartest people on the planet. I guess the only advantage is that I get to speak last, so not that many contradictions. We've heard a lot earlier today about man and machine. So when you think about man and machine, this is a story of over 300 years. When we think of steamships and transportation all the way to modern jetliners, you'd say that that enabled the global trade that really gave the benefits in the last 30 or 40 years when we talk about the globe flattening. You think of the telegraph going into smartphones and all of communication and what that enabled in terms of all of the economic benefits that have now gone on globally. You think of the surveying instrument going all the way to GPS and what that enables for everyone. This is a long, long story of decades and of all the benefits that accrue to people through that. When we go on and we think of the benefits of AI, and you think of the benefits of AI in agriculture, we did an experiment with a winery. Yes, we're on the East Coast and wineries on the West Coast, but they wanted to come and talk about water reduction with higher quality grapes, and the conclusion was 20% less water and higher quality grapes for a higher quality wine. When water is in shortage, that's important. You go to oil companies, and putting aside all our politics about global warming for a moment, I mean, they do tend to drill, and drilling in the deep sea costs lots of money, hundreds of millions, if not billions of dollars per well, and many holes are dry, and a dry well means you wasted all that money. You can improve the predictability by letting machines look at seismic maps and the data that comes back from all the experiments to decide where to drill. And a third example, I'm not going to go through all of these, is around aluminum smelting and machine learning with people who don't really know that much about metallurgy, but they can work with the metallurgist, and you can reduce a couple of % of energy consumption, which for aluminum is electricity, and a couple of % for that industry means on the order of a couple of $1 billion less of electricity, which actually means usually less coal and less oil consumed, but also higher profit margins for them. So the benefits of AI are far beyond just, and I won't talk on healthcare because it's been talked about a lot today, but I am going to talk about aging. So aging is a place where computational neuroscience has the ability to offer tremendous benefits. Some of our research colleagues looked at speech, and they looked at can speech be used to predict onset of diseases like Alzheimer's, dementia, Parkinson's, Huntington's, etc. And some early work shows that up to 2 to 3 years in advance of these diseases, you can predict their onset. By the way, if you can predict their onset, cure is yet a different place, but you can definitely manage a higher quality of life for a lot longer with that predictability as opposed to an after-the-fact conclusion, which is often drawn today. Healthcare we have talked about a lot today by many people, so I'm not going to touch on that. So we kind of get to a conclusion that it's not really man versus machine, it's really man and machine. Machines are great. A couple of speakers here have talked about machines are great at looking at large data sets. They can look at the patterns. They can do all the statistical reasoning. But when you look at the common sense, the value judgment, the self-directed goals, man is going to be a lot better, leading eventually to much better decision-making across a vast range of human endeavor. And that's really the first point I want to make. The question you'd ask is, if all that has been there, and those are things that you could sort of argue logically, then why now? The amount of data, what we're calling the digital exhaust, you can call it data sets, is increasing dramatically. 2.5 exabytes of data created every day is an estimate. Even if that's off by 50%, it's a tremendous amount of data. 90% of the data is coming in the last 2 years, which tells you it's on an exponential curve. The scientific output, somebody just mentioned 1 million articles in PubMed each year, 23 million globally. You can go across all fields, and this output is increasing, which means you need to read it in quotes, in order to understand and to be able to do something with it. The other is all of the sensors. It's not just television cameras. Sensors on homes, sensors on windmills, sensors on oil wells, on trucks, on planes. They all give you tremendous amount of information, and it's dramatically different. It's not just simple numerical data, and it's not just straightforward speech data that you can convert to text. It's all kinds of data. Vibration sensors on railway cars can give you when fatigue is about to occur. And by the way, contrary to what you hear, most derailments are due to fatigue on wheels and bearings, are not due to other things. So when you look at that, I'll make the point that AI offers the ability to get another revolution. Going back in the history of the world, there have been 5 technological revolutions, and that's work that was done by an economist called Carlota Perez. And we look at that, the Industrial Revolution driven by steam, the railways, there was electricity and heavy engineering, oil and automobiles, and the last 60 years, we'll say we've benefited from ICT, semiconductors, communications, and computers. I have a hypothesis that AI is going to be of equal scope as all of those, which means that the benefits are not just to technology and technologists. Those benefits accrue to nations and to entire economies and move the global standard of living higher if harnessed appropriately and towards the right areas. So then you say, well, can you make an analogy? The analogy I'll make is to the semiconductor industry and its growth from the 1950. 1948 was the discovery of the transistor. As you can say, that was day one. I assert we are in the equivalent of the 60s. In the 60s, computers were all there. Computers were being built on semiconductors, not on vacuum tubes. You had transistor radios, you had televisions, all those things. So it was there. We are there in AI. But there's another 50 years of massive benefit to accrue. The equivalent of a smartphone is not here. The equivalent of it being embedded in the fabric is not here. And if you look at that world GDP growth and you compare it to Moore's law, it's remarkably parallel. I mean, that's the analogy you can draw from there. So then you say, what do we need? So we make the point of the benefits. We talk about that there is a huge possibility. And what do you need? The first point was made by a couple of people. You need a lot of data. You need data not just in terms of the few hundred data sets that have been made available. I'll say you need to multiply the size of them by 100 and the quantity by 100. How about water quality? Do we have sensors on water quality everywhere? How about food safety? $80 billion a year is the US estimate on foodborne illnesses. That is avoidable if you could have the correct data. Pollution mitigation, much more of a problem in Asia and Africa than probably in the West. Aging. Aging is going to be $2 trillion of expense in the US by 2030. We're going to have a third of the population over the age of 65. Seismic exploration for all kinds of purposes. Advanced drug synthesis so that all that work on genomic studies can actually lead to the appropriate drugs. So the creation of open data sets is critical. The critical word there is open, so that people can work on them. Next, we need fundamental R&D across a bunch of sciences. Professor Ducci talked about a little bit of a theory, but that theory needs to go far broader. It needs to, do I need 15 million images? Or I'm sorry, is 15,000 enough? Well, what's the diversity in those images? Shannon came up with the concept of entropy in communication. We're nowhere close to that when we look at all of the data sets that are being used in AI. Anomaly detection. I've got a camera looking at something. Is that good? Is that bad? How do I know that that's a child falling into a dangerous situation? So that's the context piece that we could need to go need. We already touched on the analysis with privacy. Risk-based capacity planning. How are you going to go do that? How about control of viral propagations using AI? How about computational creativity? So not just bad things, good things, new recipes, new music. All of these is going to require new science, science that is yet to be done. And this kind of science is only going to be get done, I believe, with government investment in R&D. Many of the revolutions also that we all take benefit on were driven by massive infrastructure investment, massive. ARPANET was driven through investments in the 70s and the 80s. Its genesis goes back to DoD studies from 1967. I'll assert Paul Baran's paper in 67 was the genesis. Many might disagree, but I think that was day one in an Air Force conference that was published. That led to 3 decades, roughly, of government investment in infrastructure to benefits that now benefit the nation and the world. But I'll make the point that many, many US companies have also benefited from it for both employment and wealth creation. High-performance computing, an effort still going on with the Department of Energy, gives huge benefits across the board to many, many benefits. The amount of work that can be done in computational chemistry now is of benefit to how soap and beauty products are made. And that's a benefit of HPC. What will be that equivalent in an era of cognitive computing, which has got AI underneath? So when you put all this together, as opposed to being afraid, we go back to a quote by Marie Curie, one of the eminent scientists from the early 1900s. Nothing in life is to be feared, it's to be understood. And now's the time to understand more so we may fear less. AI can be bigger than the steam engine if we harness it correctly and do the right work. Thank you.